Alright, here we go. Chapter 8. We're going to be getting into similar polygons today. And before we get into the polygon part, we're going to kind of take a trip back to a review concept of proportions. So proportions are going to constitute most of the math this chapter, so I do need to go back and talk about them. Proportions deal with ratios, or they can be written as ratios. And ratios it's a comparison of two quantities. And specifically, we're going to be looking at measurements or shapes. You can write these guys as a fraction, like a over b, or you can write a dot dot b. I want you to be aware that you can toggle between those two situations. So if you're given a ratio that looks like a dot dot b, in your brain think, oh, that's like a fraction, a over b. And both versions can be reduced. Now, one thing about proportions is that order matters. Okay, especially with those little dot guys. For example, you might be like, oh, 5 dot dot 4 is the same as 4 dot dot 5 because we got 5s and 4s, we just switch them around. No. No, those are not equal. And the reason for that is if we make these guys both fractions, 5 dot dot 4 is 5 over 4. 4 dot dot 5, or how you'd read that would be 4 to 5. The ratio of 4 to 5 would be the fraction 4 fifths, or 4 over 5. And as we know, hey, those are clearly not the same. Cool. And that gets us to a key term, which is proportional. Proportional means equal ratio. Okay. You might have heard the term equivalent ratio or equivalent fractions. They all kind of mean the same thing. Now, one thing you're going to be doing is you're going to use a strategy called a cross product. Okay. And you can use a cross product to solve problems, but specifically we're going to be looking, or we're going to be using cross products to check for proportionality. Okay, we're going to check for proportionality. What does that mean? Oh yeah, we're checking for equal ratios or equal fractions. Well, here's what it might look like. You're going to be given a couple numbers, maybe 3/4 and 15 over 20. And you're supposed to figure out, are those proportional? Remember, proportional means equal fractions. Now, you could reduce both of these guys. Not going to lie, that's one strategy. But with a cross product, you just do a quick multiply in an X pattern, and that's how you get the cross name. It's not like T cross, it's a X cross. So we're going to go top times bottom. So we go 3 times 20 equals, or we don't know if it equals it, 4 times 15. And we're going to solve both of those guys, and we see 60 equals 60. If these guys are the same, boom, then we know the two fractions are proportional. Okay? So the key deal is if your cross product is equal, then your ratios are proportional or equal. Okay. So that's the review piece. You are going to be using that for the math. So let's hop to similar polygons. Similar means same shape but different size. This would be especially a good example would be like model airplanes or model trains or model horses. Again, you got the same shape or a close to same like proportions and whatnot, but the actual object is shrunk down into a toy or model size. Now, key terms, corresponding angles are congruent. And remember, corresponding means same location. Okay? Corresponding means same location. So you're going to check for making sure the angles are going to be the same measure. And then you're going to make sure the sides are proportional. So the angles have to stay the same, but the sides are going to be different. Corresponding sides are proportional. Okay. And remember, proportional means same ratio. And we have a new term, or not a new term, I'm sorry, a new symbol. It's a squiggle. The squiggle means is similar to. Okay, so it's kind of like your congruent marking, but without the equal sign. So it's just like that squiggle. That's the squiggle. And remember, the squiggle does not mean equal. It means similar. So, we're going to run one example in your notes. We're just going to go like this. Oh, that's a 6, not a 7. This image is not going to be drawn perfectly to scale, I'll tell you that right now. You just got to look at the numbers. So, if we have these letters, what we're going to do, actually I'll give you guys a second. You can pause the video if you want to copy down the picture. This is going to be our only picture we write, so I would recommend getting it in your notes. We're going to run through a similarity checklist, okay? If your shapes fit with this checklist or meet the checks on this checklist, then you know your shapes are similar. First, we're going to check the angles. if the angles are congruent, then go to step 2. If they're not congruent, you're done, not similar. Okay? So the first requirement for similar polygons is the angles have to be congruent. If we look at our picture, we see a 90, a 90, a 1 and a 2, 90, 90, 1 and 2. Okay? So it looks like we're pretty good. So now we're jumping to step 2. Second, we're going to check for proportional sides. Okay. Check for proportional sides. And if all pairs of corresponding sides have the same ratio, then your shapes are similar. What does that look like? Let's find out. So we got our corresponding angles are congruent. That's the first thing we check. And again, we see a 90, 90, 1, 2, 90, 90, 1, 2. Boom, first test is passed. Now it's time for the second test. The second test is where you are going to have a little bit more math. By a little bit, I mean a lot more. And you're going to match up the sides. Now, whatever you choose, there's different ways you can set up your proportion. I usually do a small over big. What I mean by that is my small shape over my big shape. You could also do left shape over right shape. Whatever you do, your pattern has to go for all the pieces. What do you mean by that? Wheel. Small over big. And then we're going to match the sides. So 5 is between the two 90s. 10 is between the two 90s. But 10 is bigger, so we're going to go 5 over 10. Okay, now I've got my small shape over my big shape. Now we'll go maybe 4 over 8. 4 is between 90 and angle 1. 8 is between 90 and angle 1. Those are those corresponding parts that we want to identify. 1, 2, 6, 1, 2, 12. Boom. And last but not least, 297, 290, 14. And what you're looking for is, can all these guys be reduced to the same value? Okay. Well, some of you guys might know, hey, 5/10, that's 1/2. 4/8, that's 1/2. 6/12 also 1/2. 7/14 also 1/2. All these guys can be reduced to 1 over 2. Okay? Which means that the shapes are proportional. Boom. Okay? And because your shapes are proportional, we can write a similarity statement. Similarity statements are pretty much the same thing as a congruent statement, except there is a squiggle in the middle. So what I would put here, if my shapes are proportional, now I have to pick a path that I just do the same on the other. So I can go 90, 92, 1, 90, 92, 1. So I can go S, Q, U, I, squiggle. So I got S, Q, U, I, squiggle. Now I have to follow this same pattern for my other piece. I went 90, 92, 1. Now I have to go 90, 92, 1. G, L, E, Y. Boom. And that is my similarity statement. Now, with a similarity statement, what you know is you know that the first guys are going to be, the first angles are going to be congruent, second angles congruent, third angles congruent, fourth angles congruent. So you know, just like congruent, a congruent statement, the matching angles are going to be congruent, but the sides like SQ and GL are not going to be congruent. They're going to be proportional. Okay. Now, last thing is this thing called a scale factor. Now, we've actually already found the scale factor for our problem. It is a ratio that relates two similar figures and it's the same value as the ratio of corresponding sides. You might also see scale factor abbreviated SF. So scale factor would be the same as that guy there. So we could say SF equals 1 to 2 or 1 dot dot 2. It really doesn't matter how you write it. So, thanks for sticking with me. A couple pages of notes there. I'm going to do some examples next, so please check out the examples video. Thanks for watching. Have a good day.